Hello, everyone. So seems that we are on air now. My name is Nazar Toker. I am front-end developer and YouTube blogger. And it's not my first stream here, so welcome back who is not for the first time here, and welcome who is attending Lemon.io webinars for the first time. Feel free to subscribe and hit like button. We make it pretty often, so I think it's pretty interesting here. Today we are having Leonid Nekhymchuk, who is a co-founder and CEO of Datuum.ai. And today we're going to talk about the arrival of the large language models, which are changing the data mesh and actually changing the approach that we can use to analyze and to go through the big data.
Hey, Nazar. Hey, everyone.
Hello. Nice to see you again.
Happy to be here. Yeah, good to see you again.
Okay, guys, just as a friendly reminder, we are today waiting for your comments. Feel free to hit comment on the YouTube chat, and we are going to choose. Actually, Leo is going to choose the most interesting questions in the end of the stream, which I think would be not more than 1 hour. And the author of the best comment or comments will get a cool hoodie from Lemon.io. Okay.
I'd be happy to actually award the hoodie to myself, but yes, to be fair, we will look for the best question, best comment, and yeah, we won't get the hoodie for us. I promise.
Okay, so what I'm not a big master of AI and data meshes and all that stuff. So I'm gonna ask something that is on my mind about that. So we have big data. Big data is it's changing the world now. Yeah, so we can analyze it. We can make requests to get some stats, to get spikes in sales data, to understand what is going on the support chats, whatever. And in this case, we have large language models, which are LLMs, and the data mesh. How do you combine them, and why we need it? Can you explain just like in briefly?
Yeah, obviously data itself and data mesh and LLMs in particular are very, very big topics that will take hours and hours to discuss. But in combination of those things is a very interesting topic in itself. So before we start exploring this thing as a great combo of data mesh and LLMs and big data, let's take a step back maybe, and for those who don't have a lot of experience in this area, explain what is the data mesh and why it even exists and how it is related to the big data and everything data related. So as you mentioned, data is a new oil, new gold, or new bacon, like some people call it. And every day the humanity produces more and more data, and people are building tools, people are building different technologies to handle all of it, right? To serve data to the right users at the right point of time. And it becomes very challenging because every organization depends on data so much these days that it's really hard to give people what they need to support decision making at all levels. So the typical architecture or framework that people invented a long time ago is in a very simple terms is the following, right? You have multiple data sources. Let's figure out how to get data from every data source, put it into one place, join all those different data sets together, and give people access to this one centralized storage. So data is curated, data is normalized, data is verified its quality, and people will be happy. And it worked for many years, decades actually. But then those people who are supposed to be happy became very unhappy. And the reason for that is that this centralized place became a bottleneck, right? And people who were in charge for this centralized storage, whether we used to call it the data warehouse, and then the data lake, and then a combination of lake house and lakes and warehouses and data marts of all sorts. But the core concept was there's a centralized storage of the data, which people are kind of building and curating, and those people became bottleneck. The centralized place became a bottleneck. And what data mesh is, it's a basically new paradigm, new framework of how to decentralize this one behemoth of data into a set of so-called data products, and give those data products in the hands of domain experts, people who are experts in sales data. They create a sales data product. People who are experts in CRM data, they are experts in their data product. And by doing that, you remove that bottleneck, and you kind of democratize the access to the data. So people have more access, more control over their data, and at the same time, those products evolving without a centralized bottleneck that was a big problem before the data mesh architecture.
Okay, so if we're talking about large language models, you're talking about some kind of structurized data, which is tables, which is like databases, but the database can differ a lot. Yeah, having different structure, different type, different fields, and etc. And as far as I get, LLM in combination with data mesh can combine all these different kinds of data and to give you results based on your queries.
Yeah, it's a great question, and actually everything I just described about the data mesh was created before LLMs became like a hot topic, right? But then people started thinking, okay, we have this data mesh framework, and it has its own challenges, right? It's not a silver bullet that fixes all your organizational issues with the data. It's fairly hard to implement. It's there is a risk of creating data silos, creating isolation for the data. It might be complex for people to grasp as a whole. So there are certain things that you can get into troubles implementing the data mesh framework. So the rise of LLM, actually, why it's important, why it's interesting in the concept of data mesh framework, is because LLM can address many of those risks, right? So for example, when you implement a data mesh framework, one of the most important features of it, or like byproducts that data mesh depends on, is your semantic layer, right? The semantic layer that explains every single bit of information in your data mesh framework, that connects all different data products and makes sure that people are not duplicating things or interpreting things differently in one product versus other products. So typically that's one of the hardest steps in implementing a data mesh framework. And an LLM, by nature, understanding a lot of semantics in terms of data and can understand what is this data, how it's structured, help people to understand a lot about a particular data set and data product, and actually fill in this semantic layer is a great tool to actually help not only build this semantic layer on top of your data product set, but also maintain it and give people an interface, if you get to it, where an LLM understanding your semantic layer and all the data underneath it, you can basically ask question in simple English, and an LLM, which is aware of your data, will interpret this question into set of SQL queries, potentially give you an answer. So the combination of a data mesh framework as a concept and LLM is one of the tools that can really help and address certain challenges in implementation of data mesh is a very powerful combination that many companies are exploring these days. And it looks very, very promising, because implementing the data mesh is a big undertaking, right? Regardless of how complex your data or big your data is, it's a big organizational kind of mind shift, and it requires a lot of time and resources to do that, and especially to do it right, not just say like, oh, we have a data mesh because we bought this cool tool. But a lot of companies right now are, more positive about implementing data mesh in a foreseeable future because of the help of LLMs.
Okay, Leo. So when you're saying about semantic layer over the information, does this mean that the let's say marketer or salesman can just Google for some information over dozens of databases of the company? Do I get it right?
Yes, that's one of the great products of having an LLM aware of your data and your semantics, because there are two main kind of things. You can do what you just described, right? You can ask a question in simple English, and an LLM will produce it like a valid SQL query, for example. It might not be just SQL; it can be Python or something else. But also building this semantic layer is the hard part, right? Combining all the data, analyzing all the data, and building it into like comprehensive layer that describes all your data products and through which you can understand them, is where LLM actually shines and eliminate a lot of effort and a lot of time.
So let's say one marketer types in the comment which is saying, "Dear LLM, please let me know what's the most significant spikes we have in sales over last 5 years," and without knowing any kind of SQL commands or understanding what is the difference between PHP and C++, the person will get the information in readable view.
Yes, that's definitely possible. But again, when you're typing this question and asking like, show me the sales number, what is the sales number, right? Because for you, sales is what? The for example, number of units that people sold. For another person, it's sales is a number of products that you sold and people don't return, right? Which might be a very different number. So the key concept of this semantic layer and why it's important to build it is that you can ask and get an answer what it actually is, right? What is the sales? When you see it for the first time, you're a marketer, right? And maybe you don't know the definition of this metric, but you're like, give me the number of like sales for the last quarter, and it will give you a result, and you can interpret it in your own way. So the very important part of the data mesh and this whole semantics definition is to have an ambiguous description of every data element and every metric within the organization. So people from different departments, different parts of the organizations looking at this number, all of them interpret this number in the same way, whatever it might be.
People ask for more real world examples in the comment section.
Well, yeah, I've implemented data mesh architecture in a couple of times in my life. It's how does your product support the creation and managing the data domains and LLMs? Oh, it's a very, very good question. So a little bit about Datuum.ai first, as this question came first, and how our product supports the creation of data mesh as one of our use cases. So what Datuum.ai does, it's a AI-powered data integration tool that uses the power of AI to understand the data, interpret it, create a data product, publish a data product, and it doesn't require any engineering or coding skills. So our user is a data analyst who can actually use the power of AI to automate many parts of a typical data integration project, from the inception to creation of a data product. And Datuum provides a great user experience to do that. So we help companies to implement different data products, different frameworks. If we talk about the data mesh in general, Datuum is just one piece of the big data platform that a company needs to implement a data mesh. So it's not like with Datuum you implement the data mesh. And data mesh architecture in general, it's not about the technology, it's more about the organizational structure and the paradigm shift in terms of the data ownership and data decentralization. It's more a project to change minds and the structure and how the organization interacts with the data than it's about the tool. So it's less technical, more organizational implementation, if you will, at least in my experience, because and that's a great segue actually to talk about real life examples, because whenever people think about implementation of data mesh, everyone gets excited, right? It's especially engineers, because it's a very cool concept, and it promises a lot of benefits if you implement it right. But what people don't realize, at least in my experience, is, again, it's more about the organization and politics, if you will, than actual technology. In my previous company, we implemented sort of a data mesh architecture where we decentralize our product ownership, data product ownership, creation and maintaining of data product in a kind of a pods infrastructure where every team was self-sufficient and implemented its own data product, was responsible for its creation and evolution as like a true product. So every team has data engineers, product managers, QAs, infrastructure people, and it created independency, and we could implement a lot of things in parallel. The downside of it is actually the data governance, right? The data governance becomes much more important and much more complex, because instead of governing the centralized storage of the data, you have to take care of several different teams that operate on a very different schedule potentially, and the data overlap, but teams, they kind of busy and not talking to each other as they think that their product is the most important one and they are very proud of it. So creating this umbrella of semantics, umbrella of data governance, and bringing those products to life at the same time, at the same cadence, is a big challenge. So again, it's not about the technology per se, it's more about the organizational challenges when you implement it. But the benefits are great. The benefits is that you remove the bottleneck of complete centralization. You can do much more things in parallel. You create more agile, nimble data products which can change on their own schedule and create much more benefits faster for the users, instead of trying to change one big clunky data warehouse that everyone wants to change its own part, but since it's a one big thing, it becomes really hard in terms of coordination and synchronization of those efforts.
So when you're saying decentralized, it's not related anyhow to blockchain, which at first thought it's not.
No
Yeah.
No blockchain. Well, maybe in the future, who knows? But not that I'm aware of.
Yeah, I think the blockchain guys would hang themselves when seeing the amount of data but that is possibly could be stored there in a blockchain. So it's a pretty big data.
Yeah, I mean,
anyway.
when companies start thinking about things like data mesh framework, implementation of data mesh framework, which is, as I mentioned, a pretty big undertaking. We are talking typically about hundreds of terabytes or petabytes of data. So typically people start feeling this pain of centralized approach when there are many different people involved, big data sets involved, long implementation cycles involved. So typically it's like a mature big infrastructure company, like with the huge companies with big infrastructure and pretty big data footprint.
Okay, so in order to start working with LLM in combination with data mesh, the company would need companies like you or something similar to implement this semantic layer and analyze databases, and later the result of your work can be used by any kind of user without any technical knowledges, it's not a programmer, not a software engineer at all.
Yeah, you can say that. Again, the company, every company can decide when is the right time to start an implementation of a data mesh or similar framework, LLMs just make it much easier these days. I'm really glad that LLMs became so popular and they are getting more and more into the data world, where we see things like an LLM can be your own data analyst, right? It can produce an Excel with analysis and can produce visualizations of the data, recognize patterns, work as your data analyst to QA the data, and all those great things. But and implementation of a data mesh framework can become much simpler with LLMs. When is the right time? What is the right company? Again, in the implementation of such a framework, you will need a lot of tools, starting from creating the semantic layer, data catalogs, data pipelines orchestration, different types of databases.
Which is meaning updating data, not only working with the one that you had already.
Of course, yeah. The data flows constantly, right? Data flow should never stop. So whether it's a batch updates or real-time data streams, the data should flow all the time. So that means that you potentially need a lot of different pieces of technology. Not like Datuum can provide all of it at once. There is no such thing as like one size fits all these days in terms of the modern data stack. But yeah, Datuum can be one of the components for successful implementation of a data mesh.
I see another question from Natalia, which is, would linked data structure instead of using LLMs help to avoid possible problems with data that went through the data mesh framework? What would you say?
Linked data structure instead of using an LLM helps to avoid possible. Well, I'm not sure I'm like 100% familiar with the linked data structure, what it is, but I can assume that I can say that things with LLMs are not mutually exclusive. So the immersion of LLMs in a data world doesn't replace necessarily some of the concepts that existed, right? Or they produce new concepts. They just make easier to do certain things. For example, a human being can be asked like, hey, we have a corporate database. It's been there for 10 years. We need a sales report, like Nazar's favorite report, right? Can you go there? We know this data is there. Can you go there, analyze this database, and figure out write a query and figure out what it is? There's nothing new about this concept, right? You open this database, you see hundreds of tables, you potentially see the structure, the relationship diagram, all of that. And it can be very poorly modeled and very poorly implemented database, or it can be perfect, which rarely exists, but for the sake of argument, let's say it's greatly designed, maintained, and people documented everything about it. Still, it's a new thing for you. In order to write a query, you can spend some time understanding where the data that you need is and how to write your query. So again, regardless of the situation, an LLM can be your co-pilot, your assistant in terms of analyzing the source data, understanding where the data that you need is, what it means, how it's related to other data sets, and potentially writing a query for you or helping you to write a query. So again, back to your question, it's not like LLM replaces something, at least in my mind. It makes certain things much easier in the data world.
So another comment is one could start with quality improvement of the data, making it linked. Then there will be not problem like duplicates while using data from different distributed data sources. Yeah.
Yeah. Thanks for the comment. Understand what you meant by that. But again, all those, exactly like explained, all those things and LLMs are not mutually exclusive things. They are complementary to each other.
So you can combine them.
At least in my mind. Yeah. Again, the LLMs can help a lot.
Before proceeding, I would like to remind that this comment section is the easiest way to get a free cool T-shirt and the hoodie from Lemon.io. So feel free to. There's not a big competition here in the comments, so feel free to shoot your questions in the chat, and you'll have a chance to get one. You mentioned that it's important to get a big amount of information to work with, yeah, and to make queries, whatever. And there's an important question, Rex, about the security of the private, let's say, sensitive commercial data. Yeah, if company wants to analyze my favorite sales information or support information or anything else, some of this information can be really sensitive and not to be shared with third-party applications. How do you manage these kind of questions?
That's an excellent question, actually. One of the first things that I asked ChatGPT when it became available was like, do you store my data? And the answer was yes. And then I asked, can I ask you to remove the data? And the answer was no. And there was an explanation why it's impossible. It was impossible at that time to remove the data. And OpenAI made it very clear from the very beginning that they would use the data that you put into chat with ChatGPT. So naturally, that represented and still represents a huge challenge in the corporate world of using those public services. And we heard a lot of scandals already with different big corporations where very sensitive information leaked into the public public cloud and internet, where people just used different LLMs publicly available and gave them very sensitive corporate proprietary information, and that became a big problem. It's a big security issues, and the popularity of ChatGPT made a lot of security officers caused a lot of security officers sleepless nights, and I'm sure about that. Don't envy those guys. But with the challenge and demand came a solution, right? Currently, if you want to use a publicly available LLM, you can do so in a fairly enterprise setting. So, for example, one of our clients that we help to build a data product with an LLM uses Microsoft Azure Cloud, and you can go to terms and conditions, and you have if you have a like a business subscription with Azure, they tell you like, we will not use your data, we will not train our models using your data, you will not train, we will not communicate this data within Microsoft, blah blah. So they kind of assure you that within an enterprise setting, your data won't be used elsewhere. So that gives some companies some level of confidence and some level of comfort that this data is, at least not publicly available in the internet. And obviously, a lot of companies are not satisfied with that. So there is another option. You can use and host your own LLM within your environment. There is obviously every company wants to have little chat GPT that is aware of its corporate data and that can actually work within the corporate setting. And you can use open source LLMs. You can train them, fine tune them, host within your environment, and make sure that your data is safe.
I came across that there was a question from Sergey, and by the way, it was exactly about the same that I was talking about, which is how to ensure that sensitive data remains protected while still complying to the principles of data mesh, while encrypting the data within the decentralized data domains have any side effects. About the protection of the data, you already told. And what about the, let's say, side effects? I don't know what side effects can be here.
Yeah, every additional barrier to the data, philosophically speaking, adds a level of complexity, right? Sergey, first of all, thanks for the question. Great question. So things like encryption, things like tokenization, things like distributed architecture, they all add complexities. They all add additional layers of complexity and additional barriers to access the data for the good reason, right? For security, compliance, you cannot expose your data. You only have to show minimal required data to the users to do their job, especially in a highly sensitive data environment, like, for example, healthcare or banking industry. So yes, there are side effects. It adds complexity. It adds a lot of cost. There are ways to overcome all those compliance and security barriers. Be secure, be compliant, and still implement data mesh. It will just take longer. It will add cost. It will add complexity.
Okay, let's say the information is totally secure within the organization, okay? And the organization itself is pretty big. And you have to determine what kind of information could be available to different workers, to different teams. Can you, let's say, easily detect and protect your information from leaking to the workers within the company, which should not be available to those people?
Yeah. Again, the short answer is yes. At the same time, on the other hand, there is no such thing as like absolutely protected information. If someone has access to it, there is already risk, right? The whole security and cybersecurity, especially, it's about risk assessment and risk mitigation, but trade-offs, risks versus cost. There is not such a thing as like 100% protected information, but there are hundreds of great tools available on the market where you can fine-grain your security to the level of perfection. Again, it will be expensive. It will be, expensive to implement and maintain. Will be time-consuming. But yes, absolutely, there are great technologies that you can leverage to fine-tune your data data access to the level of a cell in a big database table.
I'm wondering how universal, how reusable these kind of LLMs are. Let's say we have one data mesh, one big organization that is working fine with the LLM in combination with data mesh. Can we reuse this LLM, let's say taught, educated on this kind of information on other company, saving costs?
Yeah, LLM on this, in a, main concept that we are bringing here into our discussion, we are talking about the, publicly available services like OpenAI or Google, Bard, stuff like that. So to answer your question, let me start with the comment that to bring an LLM into your organizational data is fairly easy at the beginning, and the entry level is fairly low. The entry barrier is fairly low because LLM is trained on so much public data that it can almost naturally understand a lot of the data structures that you have based on the data you have, and that's just great. And you can fine tune it with your semantic layer, with your data structures, and by doing that, make it even more aware of your organizational data structures, and it will become more and more aware and smarter over time. To transfer this knowledge to a different organization, personally, I've never done that myself. I would assume that there will be some overlap, but I would say that this public knowledge of an pre-trained LLM is already gives you the most of the benefit. So I don't think that the specific knowledge about your organizational data structure will be relevant in a different organization. That's what my guess is anyway at this point.
Mm-hmm. You mentioned in the beginning of our talk, you mentioned about data silos and the possibilities of emergence of such stuff. Can you explain furthermore what's this and what is the data isolation in this case?
Yeah, data silo is a fairly common term in the data world. So basically, what it means is that in a big organization, when this organization is growing and producing more and more data, certain pieces of data start living its own life, right? And became kind of isolated data sets that called data silos that are not aware of any other pieces of the data within the organization, and other data sets within the organizations not aware of that. So this is a typical, like, you don't have a comprehensive picture of your business from your data because you have number of data silos that are not covered by the common, semantic layer and data governance, and they don't talk to each other. So the answer originally was, okay, let's create a centralized place and put all this data together. And in this centralized place is an answer to all the questions. So again, the data mesh is like, okay, we've done that. It doesn't really work well. So let's split it back, right, into set of data products. And there is a risk that implementing data mesh in our own way will introduce data silos, right? Because you're splitting, you have independent teams, independent data products. So if you don't build this umbrella of data governance on top of this framework is a like kind of core foundation or umbrella, whatever you like, you may introduce those data silos that are, again, will be independent. You will not have a proper data governance, proper data management, and not a complete picture of your business through the data. So yeah, this risk exists. And actually, I see LLM helping to mitigate this risk greatly, because LLM can quickly understand your data and how it can be connected to different data sets. In fact, at Datuum, we do exactly that. We can take multiple data sources or multiple data products, and AI will figure out how you can combine them into one or a new data product and transfer the data from multiple sources into a new product with without writing code, and AI helping you to understand this data and how to actually build this data pipeline.
Are the LLMs good at predicting and building trends?
Yes, I think it's an emergent theme within the LLM world. Things like Code Interpreter by OpenAI, actually, people consider it as like your personal data analyst, like pocket data analyst. You can feed it with data and ask for like trend analysis, anomaly analysis, visualizations, and interact it with the plain English, and and it will help you to automatically build all of those. But the question here is like, how good is your data to start with, right? The LLM can give you a lot of answers, but those answers will be as good as your original data. And have the original data right and have it ready to be ready for trend and anomaly analysis, you need to build those data products. You need to combine those data sources and bring the data set, clean it, normalize it, harmonize all those different data sources into one product that you can then feed to an LLM or a human data analyst and ask same questions, right? Like, can you build me a trend? Can you build Nazar's favorite sales report, and find anomalies and outliers?
Mm-hmm. Okay, guys, we are going to be ending soon, so feel free to shoot your messages or your questions to the chat. And I see two new ones, which are: what are typical questions companies try to answer by using the improved LLMs model?
What are typical questions? All kind of questions. I wouldn't say there are typical and not typical questions. It really depends on the company, but people ask LLMs and use LLMs right now in the data world for all kind of questions, starting from the data quality, all the way to building trend analysis and using LLM as a kind of data analyst's co-pilot. So all kind of questions. I wouldn't say there is something that really stands out from everything else.
Sergey asks, as far as I understand, the solution is supposed to help the big companies organize and manage their data sources. Are these other ways for small businesses to benefit, or will it be an overhead for them? Yeah, that's a great question, I think.
That's a really good question. That's a really good question. In my experience, the companies start looking at things like data mesh or data fabric or frameworks like that, data virtualization, when they already have kind of multiple data sources, a lot of data. That centralized approach starts failing here and there. It's long, expensive, yada yada yada. So typically, it's more for bigger companies. Let's put it this way. But it doesn't mean that a smaller company cannot utilize certain concepts of a data mesh or data fabric to avoid certain issues in the future. So I don't. Again, it's a trade-off, right? The cost versus time versus quality. So I would say that don't get too fancy and too complex at the beginning. When simple and straightforward solutions work well. If you start seeing certain things failing, then you have to fix them. So to summarize that and rephrase that, yes, typically bigger companies, but it doesn't mean that you can't use certain pieces and concepts at any stage.
Mm-hmm. So, well, rephrasing this, I assume that this is pretty expensive solution.
Well, typically, if you're an established company with certain data assets already, with teams of people, making this paradigm shift is not only expensive, it's hard. It's a lot of organizational changes. It's a lot of mind shift for people, the way they treat the data, the way they assume the data flow, and roles and responsibilities change. So it's not only about the cost. It's more about the organizational shift and organizational change. And not every company can successfully implement that just because of that reason, even if they have money.
Yeah, it's also probably not in the terms of costs, but in the terms of the benefits that are the possible benefits of the solution. Yeah, so when the company, let's say, can spend hundreds of thousands of dollars to implement any kind of LLM with data mesh solution, they will save $500,000, yeah, or maybe $1 million a year. In this case, it's worth that. Well, just as an example.
Yeah, obviously.
Yeah. Okay, so it seems that we are going to end the stream soon, and I would like you to choose the best commenter, the best question from the comment section.
Really hard question. I wanna pick two people, but it must be just one?
Well, I think we can benefit two people at once.
Well, I think that Natalia and Sergey asked really good questions. So I would definitely like to point out those two people. So, but if we can send the hoodie to two people, will be great.
Yeah.
But
So
I
thank you.
don't have a hoodie, so that's not my call, unfortunately.
We can even ask Lemon to provide you with one hoodie, so you will have it. As far as I see, we have Yulia under behind the screen. Thanks for her help with the stream as well. And feel free to check the description to the video. There will be links to Leo's LinkedIn and website with more information. Probably, as far as I know, there will be a text version of this conversation, and I hope, if I'm not wrong, of course, Yulia will add it to the description as well. So thank you, Leo. Thank you guys for having for spending your evening time with us, and thank you, Leo, for a great conversation.
Nazar, thank you very much. Thanks everyone who watched and listened to us. Really appreciate your time and really appreciate the questions. It was fun. Thanks.
Yeah, thank you all, and see you on the next one.
See you.